Hello, class 12. Today I'm going to discuss about a continued part of method of substitution. We're giving some problems there in a previous video. I've given some problem solution. Something like 10 or 15 problems are there. Okay. So now I'm going to provide some more some examples on related to method of substitution. So method of substitution, that's our second class of method of substitution related problems. Okay. So the first problem is integration cube root cos square x into sin x dx. Very easy one. Just substitute cos x as z or t, whatever. Cos x, differentiation of cos x will be minus of sin x dx. That will be dt. So sin x dx will be sin x into dx will be minus of dt. So that will be cube root of t square. Sin x dx will be minus of dt. Hence that will be minus of t to the power 2 by 3 into dt. Now the integration of t to the power 2 by 3, that will be t to the power 2 by 3 plus 1 divided by 2 by 3 plus 1 plus c, where c is the integral constant. So that will be 3 by 5 into t, value of t will be cos x. So after putting the value of t, the result will be minus 3 by 5 cos x whole to the power 5 by 3 plus c. That's our first problem. Very easy problem. Just substitute cos x as t and you will get the differentiation result, that is sin x dx equals to minus of dt. Now we are substituting this one by dt, minus of dt, and cube root of cos square x will be cube root of t square, and we all know that will be t to the power 2 by 3 dt. Now integration of t to the power 2 by 3. What's the formula? We are using just this formula, standard integral formula, that is x power n dx. That will be x power n plus 1 total by n plus 1. We all know that, plus c. So we are using that formula here, and the result will be minus of t power 2 by 3 plus 1 by 2 by 3 plus 1 plus c, and the result will be 3 by 5 into, after putting the value of t here, that is cos x. So cos x whole power 5 by 3 plus 6 plus c. That's it. That's our problem. Then the second problem is something like e power sin inverse x whole square, total by under root 1 minus x square dx. Very easy problem. Just substitute sin inverse x as t. Then you will get the differentiating result, that will be dx by under root 1 minus x square, and that will be dt. Right hand part will be dt. So clearly we can say that e power t whole square dx by under root 1 minus x square will be transferred to dt. So that will be dt here, and e power sin inverse x, that will be e power t whole square, that will be e power 2t dt. Now the integration of e power 2t will be e power 2t total divided by 2 plus c. Now value of t is, we all know that, sin inverse x here. So that will be e power 2 sin inverse x total by 2 plus c. That's our second problem. Very easy problem. Just we are substituting sin inverse x as t. So differentiation, after the differentiation, the sin inverse x will become 1 by root under 1 minus x square. Hence that will be dx by root under 1 minus x square, and t, after differentiation of t, that will be dt only. So dx by root under 1 minus x square will be dt. We all know that. So we're just substituting this value dx by root under 1 minus x square as dt. Now that will be e power t whole square. So e power t whole square means e power 2t, right, and into dt. Now we all know that this is in standard form, and in standard form integration of e power x, we all know that e power mx, we all know that, rather we can say that e power mx, integration of e power mx will be e power mx by m plus c, and that is e power 2t here. The value of m is 2 given here, so that will be e power 2t divided by 2 plus c. And next we are putting the value of t, and that will be e power 2 sin inverse x by 2 plus c. Very easy problem. Next we are moving on to the third problem. Third problem is integration 1 by x log x whole square, 1 by x log x whole square dx. We are just computing log x equals to t. Then after differentiation, we all know that log x differentiation will be 1 by x into dx, that will be dt. So 1 by x dx will be dt, and we all know that log x is equals to t, so that will be t square dt. Now integration t square dt, that will be t cube by 3 plus c, where c is the integral constant. Now value of t is log x, so log x whole cube total by 3. Very easy problem. So that's our answer actually. Okay, so after that, next problem, fourth problem. Our fourth problem is integration x square e power x cube into cos e power x cube, cos e power x cube dx, cos e power x cube dx. Now what will be the procedure here? Actually we need to substitute this one, e power x cube as t. So the differentiation result will be e power x cube. We all know that e power differentiation of e to the power something will be e to the power that part. Okay, into, after applying chain rule, differentiation of x cube will be 3x square dx, and that is equals to dt. And we all know that e power x cube into x square dx, the result will become dt by 3, right? So that will be x square, look at this one, x square e to the power x cube and into dx, that's our dt by 3. So we are putting here cos of t directly, because e power x cube we have considered it as t. So the remaining part will be dt by 3. And we all know that integration of cos t is sin t total by 3 plus c. Now sin t, t is, we all know that e to the power x cube divided by 3 plus c, where c is the integral constant. That's our fourth problem. Now we're moving on to the fifth problem. Fifth problem is 1 by x square, integration 1 by x square cos square 1 by x dx. That's our fifth problem. Now what will be the substitution here? You all know that, you guessed it right, actually 1 by x we are going to substitute 1 by x as t, then differentiation of 1 by x will be minus of 1 by x square dx, and that will be dt. So 1 by x square dx, that will be minus of dt. So 1 by x square dx, that will be minus of dt. Okay, we'll write it here. And the remaining part will be cos square t, right? Because we have considered 1 by x as t. So that will be minus of integration cos square t dt. Because 1 by x square in dx, 1 by x square dx is represented by minus dt, and cos square 1 by x will be represented by cos square t. Now just adjust it with half. Then what will be the result here? We are getting the result 2 cos square t, right? Now 2 cos square t, if we apply the formula of multiple angle, the result will be 1 plus cos 2t. We all know that 1 plus cos 2t. Now the rest part is very easy. That will be minus of half dt and minus of half integration cos 2t dt. That's our problem actually. Now that will be integration dt, that will be t by 2. And integration of cos 2t, that will be sin 2t total by 2 plus c. That's it. Now where c is the integral constant. Now we have considered t as 1 by x. So after putting the value of t, the result, final result will be minus of 1 by 2x minus of 1 by 4 into sine 2, t is 1 by x, so that will be sine 2 by x plus c. That's our problem. Very easy problem, but tricky, little bit tricky. Just you need to remember that you are going to substitute 1 by x as t, and the remaining steps will follow very easily. Just look at this point. You are going to substitute 1 by x as t, and the differentiation part is 1 by x square, and 1 by x square dx, that will be minus of dt. Just substitute it here and you will get the result minus of integration cos square t dt, and rest part is very easy. We were just adjusting with 2 to obtain the formula of multiple angle, and that is 1 plus cos 2t, and we all know that integration of 1 into dt, that will be t, and cos 2t integration sine 2t by 2. That's it. Problem solved. So that's our fifth problem. Next, the sixth problem. Sixth problem is integration sine log x. Integration sine log x. Integration sine log x divided by x dx. You need to compute log x as t. Now we all know that 1 by x into dx. Differentiation of log x is 1 by x, we all know that now. So in that case, log x differentiation 1 by x dx, and that will be dt. So we are getting dx by x equals to dt, and that's our dx by x. That's our dx by x, and dx by x is substituted by dt. So what will be the result here? Integration sine log x. Log x we have substituted by t, so that will be sine t, and 1 by x dx will be substituted by dt. So sine t dt. Now we all know the formula of sine t, integration of sine t, and that is minus of cos t. Minus of cos t plus c, where c is the integral constant. Now just put the value of t here. T is log x here, so that will be minus of cos log x plus c. That's it. Our problem solved. That's our sixth problem. Next, a very good problem, seventh. So our problem number 7 is integration root under cot x dx divided by sin x into cos x. In case of this integration, I'm going to adjust the denominator part by a sin x. That is, I'm going to write sin square x here, and it will be adjusted by a sin x there. So the total part will be root under cot x dx divided by sin square x, and we all know that cos x by sin x, this is equals to cot x, right? So when we're writing this one is cot x, automatically root cot x will cancel cot x, and the result will be cos x square x divided by root under cot x, right? Because reciprocal of sin x is always, we know that will be cosec x. So we're having 1 by sin square x, so that will be cosec square x dx, and the lower part will be, after cancelling root cot x by root cot x, the lower part will be root under cot x. The denominator part is root under cot x. Now I'm going to substitute it by cot x equals to z square, and you know the result actually. Cot x, differentiation of cot x is minus of cosec square x dx, and that's equal to 2z dz. Hence cosec square x dx will be minus 2z dz. Okay, minus 2z dz. So this one will be minus of 2z dz, and root cot x will be z. So after cancelling z, we will get minus 2 integration dz. So after the integration, we will get z. So the total result will be minus 2z plus c. Now z is equal to root under cot x. So that will be minus 2 root under cot x plus c. That's our actual answer. So that's our problem number 7. Now we are going to move on to the problem number 8. What's problem number 8? Problem number 8 is integration x cube dx divided by x square plus 1 whole square. X square plus 1 whole cube. That's our problem number 8. Now what we are going to do here, we are going to break x cube as x square into x dx divided by x square plus 1 whole cube. I'm just going to substitute it by x square plus 1 by x square plus 1 by z. So after substituting x square plus 1 as z, we will get the result derivative of x square plus 1, that will be 2x into dx, and that will be dz. So x dx will be half into dz. So this part going to substitute it by half into dz. Now you all know the value of x square, that will be z minus 1. So that will be z minus 1. X dx will be half into dz, and x square plus 1 is denoted by z. So that will be z cube. So total part will be z by z cube, that will be dz by z square, and that part will be half into dz by z cube, right? Now integration of dz by z square is very easy. We all know that what will be the result here. Integration dz by z square will be z to the power minus 2 plus 1 divided by minus 2 plus 1 minus half into 1 by z cube, that will be z to the power minus 3 plus 1 divided by minus 3 plus 1 plus c. We all know that. So in that case, the total result will be minus of 1 by 2z, and that will be plus 1 by 4, 1 by z square. Why? Because minus 3 plus 1 yields to minus 2, and right before that we have minus half, so that will be plus 1 by 4, and z power minus 3 plus 1, we all know that that will be z to the power minus 2, and in that case z to the power minus 2 can be represented by 1 by z square. So total result is this. Okay, now we have to put the value of z here again. So the total result will be 2 into value of z is x square plus 1, that is 1 by 2 into x square plus 1, plus 1 by 4 into x square plus 1 whole square, plus c, where c is our integral constant. So that's our problem number 8. Now we are moving on to the problem number 9. Problem number 9 is integration 4x plus 2 under root x square plus x plus 1 dx. Now look at this one very carefully. If we take 2 common, we'll get 2x plus 1 under root x square plus x plus 1 dx. Now we all know that the differentiation part, the derivative of x square plus x plus 1, we all know that that will be 2x plus 1, because differentiation of x square is 2x, differentiation of x will be 1, differentiation of 1 will be 0. So we are getting 2x plus 1 here. So after computing x square plus x plus 1 as z square, we will get something like this, 2x plus 1 dx, that will be 2z into dz. Okay, so we are getting 2 into 2x plus 1 dx, 2x plus 1 dx, that's part, that one, 2x plus 1 dx is represented by 2z dz. So that's our 2z dz, right? And now root under x square plus x plus 1, that will be represented by z. So that's our z. Dx part is substituted by 2z dz. So ultimate result will be 4 integration z square dz. 4 integration z square dz. Now the total result will be z cube by 3 plus c. Now the value of z is under root x square plus x plus 1 total q plus c, because z square was equal to x square plus x plus 1. So what will be the value of z? Just square root here, root under x square plus x plus 1, and just put the value here, value of z here, that will be root under x square plus x plus 1 whole power 3. That's it. The problem solved. Next we are moving on to the 10th problem. That will be, 10th problem will be, problem number 10 is integration 4x plus 3. Integration 4x plus 3 dx divided by under root 2x square plus 3x plus 1. 2x square plus 3x plus 1 dx. Here I am going to substitute 2x square plus 3x plus 1 as t square. So the result will be 4x plus 3. We all know that the derivative of 2x square will be 2 into 2x, and derivative of 3x will be just 3, and derivative of 1 will be just 0. And this is our 4x plus 3 dx, and that will be 2t into dt. 2t into dt. So that's our 4x plus 3 dx, and that's going to be substituted by 2t into dt, and root under 2x square plus 3x plus 1 will be substituted by t. So t cancels each other, so that result will be 2 integration dt, and that's going to be 2t plus c. Now the value of t is root under 2x square plus 3x plus 1 plus c, where c is the integral constant. That's our 10th problem. Now we are moving on to the 11th problem. 11th problem is e power cos square x, integration e power cos square x sin 2x. E power cos square x sin 2x dx. Now just substitute e power cos square x as t. E power cos square x as t. Differentiate it. Differentiation of e to the power cos square x will be e to the power cos square x. We all know that. And cos square x, differentiation of cos square x will be 2 into cos x, and differentiation of cos x will be minus of sin x. We all know chain rule, right? Into dx, and that's going to be dt. Right. Now what will happen here? Minus e power cos square x into 2 cos x sin x, that will be sin 2x dx, and that's going to be dt. So e power cos square x into sin 2x dx equals to minus of dt. So e power cos square x into sin 2x dx, that's going to be substituted by minus of dt, and the result will be minus of t plus c, and the value of t will be e to the power cos square x plus c. That's our problem. So the problem solved. Again, very good problem actually it was. E power cos square x is substituted by t, and then after differentiation, that's the result actually. E power cos square x into differentiation of cos square x, that will be 2 cos x, into differentiation of cos x, that will be minus of sin x dx, and that's going to be dt, right? So e power cos square x minus e power cos square x into sin 2x dx, that will be dt. So e power cos square x into sin 2x dx, that will be minus dt, and hence the result follows like this: integration minus of dt, and the result will be minus of t plus c, and we all know the value of t, that's e power cos square x. So that's our answer actually. So that's our 11th problem. Next we are moving on to the 12th problem. 12th problem is integration cot x into log sin x dx. Integration cot x into log sin x dx. Log sin x dx. Now just look at this one. If you consider this one, if you consider log sin x as t, the differentiation of log sin x will be 1 by sin x, into differentiation of sin x will be only cos x, into dx, and that's going to be dt. So cos x by sin x will be cot x dx, That's going to be dt. So cot x dx is represented by dt, and log sin x will be represented by log of t. Log sin x, log sin x is going to be represented by only t, okay, and cot x dx is represented by dt here. Look at this one again. We are considering log sin x as t. After differentiating log sin x, so I'm getting 1 by sin x into differentiation of sin x, that is cos x, into dx, and differentiation of t, that is dt. Okay, so cos x by sin x converts into cot x dx, that's going to be dt. So cot x dx is equal to dt. Okay, no problem about that. Log sin x is substituted by t. So what we are waiting for, the standard integral form, that will be t square by 2 plus c, where c is our integral constant. Now the value of t is log of sin x. Value of t is log of sin x. Okay, so log of sin x whole square divided by 2 plus c, that's our actual answer. So that's our 12th problem. So very easy problems. Those are very easy problems. Okay, next we are moving on to the 13th problem. 13th problem, that is integration sec x into log of ln sec x plus tan x, ln sec x plus tan x. That's our next problem. Here we are just considering ln sec x tan x, ln sec x plus tan x as t, because if you consider this one by t, we all know that derivative of ln sec x plus tan x will be 1 by sec x plus tan x, 1 by sec x plus tan x, and differentiation of sec x plus tan x. We all know the formula, derivative of sec x, that is sec x tan x, and tan x derivative, differentiation of tan x will be sec square x. We all know that. So I'm just putting here, differentiation of sec x is sec x into tan x, and differentiation of tan x is sec square x. Now what's going to happen here? That's dx and that's dt. Okay. Now, if you take sec x as common, we'll get sec x into tan x plus sec x, tan x plus sec x dx by sec x plus tan x, and that's going to cancel each other. That's going to cancel each other, and that will be equal to dt. So sec x plus tan x will cancel each other, and the result will be sec x dx, that is equals to dt. Okay, so sec x, that's our sec x, and that's our dx, and that will be substituted by dt, and log sec x plus tan x is substituted by t. So the result will be t dt, and the ultimate result will be t square by 2 plus c, where c is the integral constant, and just put the value of t here, and that is ln sec x plus tan x, ln sec x plus tan x, ln sec x plus tan x whole square, total by 2 plus c. That's our 13th problem. So c is our integral constant. Now moving on to the 14th problem. 14th problem is something like integration 2x by cube root x square minus 1, cube root x square minus 1 dx. That's our 14th problem. Now I'm going to substitute x square minus 1 as t cube, because a cube root has been given here. So if you derive both side after differentiation, both differentiating the both side, we will get 2x into dx here, and we will get 3t square into dt, and hence 2x dx equals to 3t square dt. Okay, no problem. Look at this one, x square minus 1 has been substituted by t cube, and the differentiation result will be 2x dx, and that will be 3t square dt. Now 2x dx has been substituted by 3t square dt divided by cube root x square minus 1. That's going to be t, no problem. So the total result will be 3 integration t dt. Now after integrating, we will get the result 3t square by 2 plus c, where c is the integral constant. Now put the value of t here. The value of t is cube root of x square minus 1. Value of t is cube root of x square minus 1. So we're just putting the value here, cube root of x square minus 1 whole square plus c. So the total result will be 3 by 2 within bracket x square minus 1 whole power 2 by 3 plus c. That's our problem actually, where c is the integral constant. That's the problem. Now moving on to the 15th problem, and that's very interesting problem. X plus 1 e to the power x dx, x plus 1 e to the power x dx, total by cos square x e to the power x dx. Sorry, x e to the power x. What will be the substitution here? X e to the power x, that's going to be substituted by z or t or whatever u, whatever. Now after differentiating, we'll get x into e power x. Differentiation of e power x will be e power x plus e power x fixed into differentiation of x will be 1 total into dx, and that's going to be dz. Okay, now taking e power x common, we will get x plus 1 dx, that is equals to dz. Okay, so the numerator part is this one, e power x into 1 plus x by x plus 1 dx, and that's going to be substituted by dz, and the denominator part will be cos squared z, because we have substituted x to the power x as z only. Okay, so that will be integration sec squared z, and we all know the integration formula of sec squared z. Sec squared z integration sec squared z will be tan z plus c. So the result will be tan z plus c. The result will be tan z plus c. Result will be tan z plus c, and the value of z is z is equal to x e to the power x plus c. That's our problem, where c is our integral constant. Now moving on to the 16th problem. 16th problem is x tan inverse integration x tan inverse x square divided by x tan inverse x square divided by 1 plus x to the power 4. We are considering tan inverse x square. Very simple substitution, tan inverse x square as z. So after differentiating, we'll get 1 by 1 plus x square whole square, right? And the differentiation of x square will be 2x only, and dx, and that's going to be dz. So the total result is, there was a dx also, so 2x dx divided by 1 plus x power 4, it is equal to dz. Hence x dx will be x dx by 1 plus x to the power 4 will be half dz. Okay, so we're substituting the value here. Integration x dx by 1 plus x power 4, that will be dz by 2. So that is our half into dz, and we have just substituted tan inverse x square as z. So that will be half into z into dz. Okay, so the result will be half into z square by 2 plus c. Now the value of z is tan inverse x square. So that is tan inverse x square whole square divided by 4 plus c, where c is our integral constant. Now moving on to the 17th problem. 17th problem is something like 17th problem 1 by, that is dx by 1 plus root x. That's the problem, dx by 1 plus root x. Now what will be the substitution here? What will be the substitution here? The substitution, you may write here x equals to tan square theta. You may write x equal to tan square theta. You may write. Okay. If it does not click, then we have to take another substitution. I'm just going with x equal to tan square theta. So what will be the result here? Dx equals to 2 tan theta into tan theta differentiation. Differentiation of tan theta will be sec square theta d theta. Sec square theta d theta. So dx is 2 tan theta into sec square theta d theta, and the denominator part will be 1 plus root over x, that is tan theta. That is tan theta. Okay. Okay, no problem. Now, what will be the procedure here? Sec square theta equals to, we all know that that is 1 plus tan square theta, right? So, that's not going to help here, I think here. 2 tan theta. Okay, no problem, no problem. I think that's going to help here. I'm just considering 1 plus tan theta, double substitution I required here, 1 plus tan theta as z. So, differentiation of tan theta will be 1, differentiation of 1 is always 0, and tan theta differentiation will be sec square theta d theta, and that is dz. Okay, so 2 tan theta will be tan theta equal to z minus 1, we all know that, and sec square theta d theta will be dz, and 1 plus tan theta will be z. So that will be 2 integration z by z minus 1 by z dz, 1 by z dz. So that will be dz minus 2 dz by integration dz by z. Now the result is 2z minus log mod z plus c. Now z was 1 plus tan theta, so that will be 1 plus tan theta minus log mod z was 1 plus tan theta plus c. Now that will be 2 plus 2 tan theta, and tan theta initially was substituted by x was substituted by tan square theta, so tan theta will be actually root under x, so that will be 2 root under x minus log mod 1 plus root under x plus c, because x equals to was tan square theta, so tan theta definitely it's going to be root under x. So that's our tan theta equals to root x. So the ultimate result will be 2 root under x minus log mod 1 plus root x plus c prime, where c prime indicating sum of two integral constant, that is c and 2. So that's our problem actually. You may do this problem in this way. If you have any better approach, you may suggest me in the comment section. Okay, no problem about that. I will just entertain that thing. Okay, next I'm going to move on to the next problem, and our next problem was 18th problem. 18th problem is integration tan x, then sec square x under root integration tan x sec square x under root 1 minus tan square x dx. Okay, now what will be the procedure here? Tan x will be substituted by z. Tan x is substituted by z, and we all know that that will be sec square x dx equals to dz. So sec square x dx will be dz, sec square x dx will be dz. So tan x equals to z, sec square x dx will be dz, and root under 1 minus, so that's actually sec square x dx. Okay, now that is tan x equals to z here, and sec square x dx equals to dz here, and root under 1 minus tan square x equals to z square. Okay, so that's the problem actually. Now we have to consider once more another substitution, 1 minus z square equals to t square. So what will be the result here? Minus 2z dz, that will be 2t into dt. 2 cancels each other, so z dz, that will be t into dt. Now after putting the value here, substituting the value here, z dz gonna substituted by t into dt, and root under 1 minus z square going to be that will be minus of t into dt, so minus will be there, and root under 1 minus z square will be t. So that will be minus of integration t square dt, right? So minus of t cube by 3 plus c. Now t was under root 1 minus z square whole cube by 3 plus c. Now what was the value of z? Z was tan x. So that was actually root under 1 minus tan square x, root under 1 minus tan square x whole power 3 divided by 3 plus c, where c is our integral constant, and that's our problem actually. Okay, so that was the problem, minus 1 by 3 and then 1 minus tan square x. You may write 1 minus tan square x whole to the power 3 by 2 also, so no problem about that. Then I am going to proceed with our next problem, 19th problem. Problem number 19 is here it has been given as integration sec power 4x, into tan x, sec power 4x into tan x dx. That's our another problem. Okay, so what will be the procedure here? Just the same procedure, just consider tan x equals to t, and then after differentiation we'll get sec square x dx, that will be dt, right? Sec square x dx will be dt here, and sec square x, I'm just going to break this one, sec square x into tan x into dx. Okay, now what will be the result? Sec square x dx, you all know that will be dt. Okay, no problem about that. Sec square x dx will be dt. Okay, tan x is denoted by t. So what will be the value of sec square x here? We all know that sec square x going to be 1 plus tan square x, right? Now, so 1 plus tan square x will be 1 plus t square. Very easy. So actually the integral part will be 1 plus t square. Sec square x dx will be substituted by dt. Okay, and tan x will be substituted by t. Done. Now what will be the result? T plus t square into t, that will be t cube into dt, and integration of t will be t square by 2 plus t to the power 4 by 4 plus c. Now value of t, what is the value of t? Value of t will be tan x, we all know that. So that will be tan square x total by 2 plus tan x power 4 total by 4 plus c. That's our problem. Actually that's the problem. Now moving on to the next problem, that's 20th problem, and that is integration x plus under root x plus 1 divided by x plus 2 dx. Okay, so what will be the procedure here? Okay, so the result is integration x plus root under x plus 1. So I'm going to break this one, x plus 2 and under root x plus 1 divided by x plus 2 dx. That's how I'm going to break this one. So after this step, I'm going to write this one as x plus 2 minus 2 divided by x plus 2, and this one as under root x plus 1. After the rationalization process, the result will be after the rationalization process, the result will be x plus 1 into root under x plus 1 total divided by x plus 2 into root under x plus 1 dx, total into dx. So in this case x plus 2 by x plus 2 will be dx, then minus 2 integration dx by x plus 2 plus, here I am going to discuss about this one, root under x plus 1 will be x plus 1, we all know that. Okay, now x plus 2 under root x plus 1 dx. That's our problem actually. Now I am going to substitute x plus 1 as z square. So dx will be 2z dz for the last part, last integral, and that is our x, that is our 2 log mod x plus 2. Okay, and that's our x plus 1 as z square. I'm writing x plus 1 as z square, and dx equal to 2z dz, 2z dz, and x plus 2 means that actually that will be x plus 2 will be x plus 1 equals to z square, so x plus 2 will be z square plus 1, z square plus 1, and under root x plus 1 will be z actually. So z cancels each other. So the total result will be x minus 2 log mod ln mod x plus 2 plus integration 2 comes outside, z square plus 1 minus 1 divided by z square plus 1 dz. After that, I am just going to shift this one, and the result will be x minus 2 log mod x plus 2 plus 2 integration dz minus 2 integration dz by z square plus 1. Now, what will be the result here? X minus 2 log mod x plus 2 plus 2 integration dz will be z, and that will be 2 tan inverse z plus c. तो ये प्रॉब्लम हो गया. तो अब क्या करना है? z is under root x plus 1, so that will be x minus 2 log mod x plus 2 here, and 2 into value of z is under root x plus 1, and minus 2 tan inverse value of z is root under x plus 1 plus c. That's our problem. That's our problem. So that is the total procedure. So that's going to be the problem. Okay, for solution of the problem, and the total problem is something like this. So that was a good problem actually. That was a very good problem. First, we need to break this one, x by x plus 2. After that, root under x plus 1 by root only x plus 2. Now this one going to be adjusted by x plus 2 minus 2, and hence the result will be dx minus 2 integration dx by x plus 2, and this one is after rationalization. So this part will be root under x plus 1 root under x plus 1 by x plus 2 root under x plus 1. Now that will be x plus 1 dx by x plus 2 root under x plus 1. Now I'm just computing x plus 1 as z square. So dx will be 2z dz. So dx will be 2z dz and x plus 1 as z square, and the x plus 2 part will be z square plus 1, because x plus 1 was z square. So x plus 2 will be z square plus 1. Now root under x plus 1 will be only z. So z cancels each other. So after that step, 2 is outside, and integration z square, that will be adjusted, that can be adjusted by z square plus 1 minus 1 by z square plus 1. So the total part will be 2 integration dz minus 2 integration dz by z square plus 1. Now 2 integration dz will be 2z, and 2 dz by z square plus 1, that will be 2 by 1 actually, into tan inverse z by a, that is 2 tan inverse z plus c. Now z is equals to root under x plus 1, and the value of here is equals to also 2 into tan inverse root under x plus 1. That's the basic problems. That's some basic problems on method of substitution. Okay, write these ones. First one is integration. I'm just giving some home tasks here actually. Dx by x square plus a square. X square plus a square. This one. This integration. Second one is integration dx by x square minus a square. And the third one is integration dx by a square minus x square. And the fourth one is integration dx by root under x square plus or minus a square. And the fifth one is integration dx by under root a square minus x square. So what will be the results here? You just need to integrate those 5 integrals, okay, and comment me about that. I'm going to come with those formulas actually. These are the formulas of the next chapter, and you just need to prove this one by the method of substitution, proper substitution, okay. Just try to solve these 5 problems, and I'm going to come back with these formulas, for proof of these formulas, and also with some techniques of regarding the method of substitution. And that's the basically that's the last part of method of substitution. Method of substitution will contain two videos related to this one. Okay, first part will deal with some theory related discussion with some typical type of problems, and second part will discuss about some specific important problems. So you now just need to stay with this channel. Okay, if you like this video, then please share with your friends, like the video, make a sweet comment there, and also subscribe the channel and press the notification bell, and just wait for my next video. Okay, ta-da.